Hi, in this video I'm going to solve the problems related to lecture 19. Below this video you will find another link that will take you to another PDF file containing a new set of problems related to the same topic that I covered in lecture 19. The reason that I am doing so is because delving more into the topic of algebra, the number of problems, exciting and more interesting problems that we can solve increases, and I don't want to miss the opportunity to present those nice problems to you. So usually from now on, I do one lecture teaching you a new topic in advanced algebra, high school algebra, and then usually it will be followed by at least two problem sessions because, as I told you, the number of problems that we can solve increases. Okay, so now let me start solving the problems related to previous lecture. Of course, you can also download these PDF file that I am solving the problems from below this video. You can also find another link for the problems that I will solve. That would be the topic of the next video. Then after these two videos are finished, then I will continue teaching you a new topic that would be addition and subtraction of rational expressions. So, okay, let me start with the first problem. Simplify the following rational expressions. So this one, number one, we are supposed to simplify this expression x to the 4 minus 9x to the 2 and then divided by x to the 4 minus x to the 3 minus 6x squared. Yes, so I am supposed to simplify this expression. So if you recall from the previous session, from previous lecture, you know that if I want to simplify a rational expression like this, I need to factorize both the numerator and the denominator, and then try to find the common factors and simplify all common factors between the numerator and the denominator. Okay, so if I want to solve this, the first step that I do is to factorize the numerator, which of course is very simple. So it becomes x squared. I pull an x squared out, so then it becomes x to the 2 minus 9. The same thing here somehow. You see that x squared is a common between all the terms. So if you have problems factoring polynomials, you can go and watch my previous videos that I extensively talked about how to factor polynomials, different tricks and techniques. Okay, so if you have followed that, I am completely sure that this is very simple for you now. So then it becomes x squared minus x minus 6. Okay, of course, here x squared is a common factor. I can eliminate it here. Yes. So this x squared and that x squared are gone. So one is left here, one is left there. So I am left with x squared minus 9 in the numerator and that expression in the denominator. But let me simplify it, let me factorize it more, because you know that this factorization is not complete. This is the conjugate pattern, so I can write it as x minus 3, x plus 3. And then this is the common identity. So you know that that's a quadratic polynomial, trinomial. I want to factorize it. So I choose the simplest way here because it's easy to guess. So I open two pairs of brackets, put an x in each of one of them, and then I ask myself, I need two numbers whose sum is -1 and whose product is -6. And I think it's easy to guess. So those numbers are -3 and +2. If I add these numbers, it becomes -1. If I multiply them, it becomes -6. And then you immediately realize that x minus 3 and x minus 3 is another common factor. So I can divide by that expression, that is one left from here and one left from there. So then it becomes x plus 3 in the numerator, and I don't need to have those pair of brackets, and then I have x plus 2. So I hope that you know that you are not allowed to simplify these x's because x is not a factor of the numerator. X and 3 are added, so that is called a summand. That's also a summand for the denominator. Only factors can be simplified, not summands. So that would be the end of this first problem. Okay, so number 2, we are supposed to simplify this expression, a to power 6 minus b to power 6 divided by a plus b times a to the 3 minus b to the 3. Okay, I want to simplify this. Again, the story is the same, so I need to factorize. Okay, so here I recognize a conjugate pattern, and if you look ahead into yourself, so you ahead of you, you will see that this, after factorization, one factor would be exactly this. So don't factorize this, because you know that this will be canceled with one of those factors, even though I can use one of those identities, the difference of cubes, to factorize this as well. So here, in the factorization lesson, the goal was to factorize as much as possible. But remember, here the goal is not factorization, is to bring out the common factors in a clear way so that I can eliminate them. Yes, so here if I want to solve this, I use the conjugate rule to factorize this as a to the 3 minus b to the 3, and then I multiply it by a to the 3 plus b to the 3. This is a factorization. Of course, I agree that this is not still the full factorization, because each one of them can be factorized more. But at least for this, I don't need to factorize it more, because looking ahead into the problem, you can immediately see that this can be factored, this can be canceled out. So then, if you don't mind, let me just write it in here, a to the 3 and minus b to the 3. And then what is left, I can simply cancel that one and that one. So 1 is left here and 1 is left there. And then you make sure that you can cancel, because these are factors, yes? Then I am left with a to the 3 plus b to the 3 divided by a plus b. Yes? Okay, but if you stop there, that would be not complete, because now I realized, if you remember, I can factorize the sum of cubes, yes, using another identity. So I can fit it here. So then it becomes a plus b, if you remember. Then I have a squared, the product of them with the opposite sign, and then plus b squared. And then in the denominator, I will have a plus b. But now you can see another common factor emerges between numerator and denominator. So I can simplify that, it becomes 1. I can simplify that, that also becomes 1. Then what is left for me is just simply a squared minus ab plus b squared. Yes, the denominator is 1, but I don't write it. So that is the simplified version of this fraction. Okay, good. So let me go to the next problem, number 3. I am supposed to simplify this expression, a to the 3 plus b to the 3 divided by a minus b to the 2 plus ab. Yes? So in this form, I cannot simplify anything from the numerator and the denominator, because they are not factors. But for this one, might be you know what should we do. This is exactly that problem. But for the denominator, I hope that you can see that the only thing what we can do is just expand this expression and simplify. So let us see what happens. Okay, so let me factorize the numerator. It becomes a plus b using the same identity over there. It becomes a squared minus ab plus b squared. And then in the denominator, my goal is not for the time being to factorize this, because there is no method that I can use directly. But if you see, if I expand this, it becomes a squared minus 2ab plus b squared. The first one to the 2, 2 times the first one times the second one plus the second one to the 2. But then I will have another ab here. So for the numerator, I cannot do anything more. So let me just write it down. But for the denominator, this one and this one can be collected into one term minus AB. And then that's good enough for me, yes, because this would be exactly one of the common factors that I am looking for. You see, a squared minus ab plus b squared as a whole is a factor of itself, of course, and this is also a factor of the numerator because that's a product of this expression and that expression. So these things are common factors, and I can safely simplify by that. One is left from here, and one is left from there after division, yes? And then what is left for me is a plus 1, a plus b divided by 1. So then the answer is simply a plus b. Okay. Now, let us go to the next problem, number 4. So, problem number 4. I am supposed to simplify this expression, a plus b to the 2 plus a minus b to the 2 divided by a to the 3b plus ab to the 3. Okay? So if I want to simplify this, I need to be able to write it as factors, both for the numerator and the denominator. For the denominator, the problem is very simple. You see AB is in common, so let us pull it out. And for the denominator, because this is the sum of two squares, it cannot be factorized using the conjugate pattern. So the only thing that I can do is probably expand them and simplify it. So let me do that. I expand this, it becomes a squared plus 2ab plus b squared. So you need to be flexible. You see, sometimes even though your goal is to factorizing things, sometimes you need to expand and simplify things. Might be you can factorize it easier. And then I will have a squared minus 2ab plus b squared. Yes. And then I will have this one, I can factor ab out, then a squared is left from the first one and b squared from the second one. But then you immediately realize this positive 2ab and this negative 2ab cancel. And then I have a squared and a squared, it becomes 2a squared. And then the same story for b squared, it becomes 2b squared. And then I have the same denominator as before. But then you realize what to do. It's not still factorized. I can factor a 2 out. So what is left for me is it becomes 2a squared plus b squared. And then in the denominator, I will have ab, a squared plus b squared. And then I can simply remove these two because they are common factors now. So this is 1 left here and 1 left there. So 2 times 1 gives me 2, and ab times 1 gives me ab. And that is the end of this problem. Okay, now let me go to number 5. So number 5, I am supposed to simplify this expression, 16x to the 3 minus 128 divided by 8x squared minus 24x plus 16. Okay? Yeah, to factorize the numerator, you see that I have a common factor here. Yes? So 16, I can pull it out because 128 is 16 times 8. Yes? So it means that, okay, the first thing that I need to do is pull 16 out. And then what is left for me here is x to the 3. And then what is left from here for me is 8. And in the denominator, I can see that 8 is again in common, so I can pull it out. It becomes x squared minus 3x plus 2. But each one of them now can be factorized more, yes? So this is the difference between two cubes because 8 is 2 to the 3, so I can use that identity and factorize that. It becomes x minus 2, and then I would write x to the 2, the product of these two with the opposite sign, which is 2x, and then the second one to the power of 2 is 4. And then you divide this by this expression, but this is also a quadratic trinomial. So these are famous numbers. This is not easy. It's not hard to guess them. So it becomes 8. And I open two pairs of brackets and put one x here, another x there. And I ask myself that I need two numbers whose sum is -3 and the product is +2. Simply, it's -1 and -2. Okay, now you see that this, let me change the color here. So this 8 can be divided by 8 one times, 16 divided by 8 two times. And this x minus 2 can be simplified by that x minus 2 here one time and here also one time. And then we cannot simplify anything more. Yes. So then what I get is 2 times 1 times this expression. So then it becomes 2 x squared plus 2x plus 4. And in the denominator, I will have 1 times x minus 1 times x times 1, which is x minus 1. Because I cannot simplify it anymore, I prefer to multiply this back. It's not compulsory, as I told you before. So then it becomes 2x squared plus 4x plus 8. And then I will have divided by x minus 1. Okay. Now, let me also solve problem number 6 here for you. I think I have enough space here. So number 6, my goal is to simplify c squared minus a squared minus b squared minus 2ab. And I want to divide this expression by a plus b plus c. Yes? Okay, as I told you before, this is mostly an exercise in factorizing polynomials. So if you have followed the videos, the previous videos on factorization, you don't have any problem here at all. So these things we have practiced a lot on the previous videos. So it is not that hard to see that I can group these things together into a quadratic polynomial with a negative sign. Then I will have the difference of two complete squares. So then it becomes the conjugate pattern, and I can follow the factorization. I can proceed the factorization. So this becomes the same. So I would write c squared. Between these three, I factor a negative sign out. It becomes a squared plus b squared plus 2ab. And then I cannot do anything with the denominator. That's a first degree polynomial in all variables. So this is already simple, in its simplest possible form. But then you realize that a squared plus b squared plus 2ab is a quadratic pattern. So then it becomes c squared minus a plus b to the 2. Yes. And then I copy and paste the denominator as it is. But now you immediately realize that I have the difference between two complete squares. So this is a conjugate pattern. So then what I can write is this becomes equal. Let me start from here. The square root of the first one minus the square root of the second one multiplied by the square root of the first one plus the square root of the second one divided by the denominator is as before. Okay? So now you see that I should be, in principle, be able to remove these brackets. It's better to remove them, but there's a negative sign. So then it becomes C. This negative sign goes inside. It becomes negative A, negative B. But this pair of brackets can be simply removed. Nothing changes. So it becomes C plus A plus B. And in the denominator, I will have A plus B plus C. Yes? But C plus A plus B is exactly identical, is equal to, not identical, equal to A plus B plus C. So I can eliminate them, and that's a factor. So then this one and that one are gone. C minus A minus B is left. So that would be the answer to this problem. Okay. Now, let me go to problem number 8. So problem number 8, let me write it here for you. It is, I'm supposed to simplify, no, sorry, problem number 7. I'm supposed to simplify this expression, a squared plus b squared minus c squared to power 2, and then minus a squared minus b squared plus c squared to power 2. Then this is divided by 4ab squared minus 4abc. Okay, I am supposed to simplify this expression for you. So what can I do? You immediately, the denominator is very simple. So you can see 4ab is a common factor, I can pull it out. And the numerator is also very simple for you now, because this is the difference of two complete squares. So what I do, I take the square root of this one, use the conjugate rule to simplify that. So then it becomes, I take it in this form. I take the square root of the first one, minus the square root of the second one, and then I do the same thing, but this time I add them. So this becomes square root of the first one plus the square root of the second one. Yes? And then I divide by this one, but let me factor 4ab out. Then b is left from here, and what is left from here for me is c. So these are the expressions. I simplified them so far. I factorized them so far. But it is not completely factorized yet. Might be we can simplify this expression. So let us do that. I remove these unnecessary pair of brackets. So it becomes a squared plus b squared minus c squared. But then I remove this. I need to multiply everything by a negative sign. It becomes negative a squared plus b squared negative c squared. And here I can remove them, this one and that one, because behind the brackets are positive signs. So that becomes a squared plus b squared minus c squared plus a squared minus b squared plus c squared. Yes, and in the denominator, I have the same expression left, 4ab b minus c. But actually what is left for me is just simplification, yes? So a squared here with this negative a squared are gone. But they are not gone. B squared and b squared becomes 2b squared. And then minus c squared is minus 2c squared. Okay, good. And here, let us see what happens. This b squared positive one and this negative one are gone. And this positive c squared and this negative c squared are also gone. Then I have a squared plus a squared, so it becomes just simply 2a squared. And then I have 4ab b minus c. But then I can pull a 2 out from here, another 2 here, it becomes 4. And if you don't mind, let me write a squared first. And then it becomes b squared minus c squared after I pull 2 out. But b squared minus c squared can be factorized by the conjugate pattern once more. So it becomes b minus c times b plus c. And I divide this by 4ab b minus c. But then this b minus c and this by b minus c are cancelled. So one is left from here, one is left from there. This 4 and that 4 are gone. One here, one there. And then finally, let me change my color. This a is divided by a one time. This a squared divided by a is a times, yes. So in the numerator, 1a, 1b plus c is left. So it becomes a times b plus c. In the denominator, only b is left. But as I told you that it's better because we cannot simplify more, I multiply it back. It's not compulsory. So it becomes AB plus AC divided by B. So that would be the solution to this problem. Okay. So let me go to the next problem. Let me do number 8. I am supposed to simplify this expression. X to the 3 plus x to the 2 minus x minus 1 divided by x squared y plus 2xy minus x squared minus 2x plus y minus 1. Yes, I want to simplify this expression as much as possible. So again, I need to factorize the numerator and the denominator. Okay. So for the numerator, I think you immediately can recognize what to do. Yes, for example, I can group them to two parts. So I can take this one with that one, and I will take these two together. Okay. So what happens? So if you don't mind, let me just solve them separately. So the numerator between this, so let me write the numerator. Is equal to, I've pulled x squared out from these two. Yes, so it becomes x squared x plus 1. And between these two, I pull a negative sign out, or a minus sign, minus 1 out. Then it becomes positive x plus minus x plus 1. Then immediately you realize that you have x plus 1 that I can pull out. Then it becomes x squared minus 1. Yes. And of course, if the factorization is important, I think in this case it should be, I can factorize even more. So then it becomes x plus 1. Then I factorize this part, it becomes x minus 1, x plus 1. But then you see x plus 1, I can write x plus 1 to the 2 multiplied by x minus 1. That's correct. That's the numerator. For the denominator, so what should I do for the denominator? Can you see that? I don't think it's that hard. You see, if I take this one and this one and the last one, they contain, all of them contain a factor of y. I can pull it out. So I am taking these, and I am taking this one and this one and this one together. So between these, the first three terms, I pull a y out. Then from this one, x squared is left. From the second one, 2x, positive 2x is left. And finally, from this one, positive 1 is left. But between these three, I pull a negative sign out. So it becomes negative. Again, the same expression appears. Then I think that you immediately see that this is a common factor. I can pull it out. So then it becomes x squared plus 2x plus 1. And then I have y minus 1. But again, you immediately recognize this pattern. That's a quadratic pattern. So it becomes x plus y to the power of 2 times y minus 1. So now the question mark that I was looking for is, instead of the numerator, I write the expression that I got after factorization. And instead of the denominator, I will write this one. Yes? But then you see that they are exactly the same factors. They are totally gone. And x minus 1 and y minus 1 are left. So that is the answer to this problem. Okay, so these were some exercises regarding simplifying rational expressions. Now we go to the second problem that we are supposed to do some multiplication and divisions. Okay? Okay. Now we go to the second problem, problem part B. Simplify each one of the following items. But this time we have actually multiplication and division. So problem B, part 1. Yes, we're supposed to simplify this expression. X to the 2 minus 4xy plus 4y squared divided this fraction divided by 7xy squared, and I want to divide this by another fraction, 4x squared minus 3xy minus 10y squared divided by 20x squared y plus 25xy squared. Okay, so that's the goal, to simplify this expression. Okay, so you know that this division should be turned into multiplication, and the price that we need to pay is to write the reciprocal of this fraction by swapping these two. Okay, and I can also simultaneously, to save time, I can also simultaneously try to factorize them, because you know that if you want to do the multiplication properly by simplification, you need to factorize again. Okay, so this, I think it's easy for you. This is the quadratic rule. This is x plus 2y, x minus, because this middle term is a negative one, so minus 2y to the 2, yes? To make sure that's right, the first one to the 2, x squared, 2 times the first one times the second one, and the second one to the 2 is that. For the denominator, I cannot do anything, so that's just simply this. But I change this to multiplication, and I am supposed to bring this expression up, but then I know that I can factor 5xy out. If I factor 5xy out, 4x is left from this one, positive 5y is left from the second one. And then I will bring this down, and I have to factorize this as well. So this factorization might need quite some time. So let me just simply do this and remove and move it there. Okay. So my goal is now to factorize 4x squared minus 3xy, then minus 10y squared. So I don't know how much you remember about this factorization, about these trinomials, quadratic trinomials, but we spent quite some time on them. So one way to do that is that I would ask myself, I need two expressions whose product, let me show it with P, is minus 40y squared. Yes, I multiply these two. I ask myself, I need two expressions whose product is minus 40y squared. And the sum, because I am thinking about this polynomial as a polynomial in x, so the coefficient of x is minus 3y here, so the sum is minus 3y. Yes? And then here, I can guess what are they. Yes? I need two expressions whose sum is negative 40y squared, and whose sum is negative 3y, and the product is minus 40y squared. Yes? You just think about the numbers. The numbers are clearly minus 8 and 5, positive 5. So the expressions are minus 8y and positive 5y. Yes? If I add them, it becomes minus 3y. If I multiply them, it becomes negative 40y squared. And if you know, if I want to factorize this, the goal is to decompose this, the middle term, as these two terms. So I would write it in this form. So it becomes 4x squared. Instead of this one, I would write minus 8xy, and then I would write positive 5xy's. So I broke the middle term based on these expressions that I got, minus 8y and 5y, and then I have minus 10y squared here. But then I can take these two together, and I can take these two together. Here I can pull 4x out, so then it becomes 4x. From here, x is left, and from here, minus 2y is left. And then between these two, I can pull 5y out. And then here you have x, and then you have minus 2y again. So if you follow what I told you here, this always guaranteed that you will have a factor emerge, a common factor emerging again. So you can pull this one out. Then you have x minus 2y, and then 4x plus 5y. So that is the factorization of this expression. I'm not saying this is the only way. If you go back and watch the video, you'll see that I talked a lot about actually factorizing the trinomials. We have different ways of doing that, so that's one way. Okay, and then I put this expression back in its place. You remember, I swapped these two. This went up, this will go down, and then that's the factorization. So it's x minus 2y multiplied by 4x plus 5y. Then if you remember, I told you that in the product, you can not only simplify each rational expression on its own, but you can also simplify in a cross-manner way, meaning that you can simplify any numerator that appears here by any factor in the denominator that appears in the denominator. So for example, here, this one and one of these are gone. So here one is left, but here we had two factors of x minus 2y. One of them will survive. And then here, this one with that one are totally gone. This is the vertical simplification. This is the cross-manner way simplification. And here we have also the same. This x here divided by x one times, this x divided by x one times, this y divided by y one times, this y squared divided by y times. And then you see x minus 2y, 5, 1, 1, 1. So 5, it's 5, and I have x minus 2y. In the denominator, I have 7, and I have a y. Every other thing is just 1. So it becomes 7y. And I told you that usually when nothing can be simplified more, I multiply this back. So it becomes 5x minus 10y divided by 7y. So that is the answer to this problem. So let me do the next one, which is B part 2. That's a mixture of multiplication and division. So I'm supposed to simplify this expression, a squared minus 4ab plus b squared, and then I have 6a squared minus 4ab multiplied by 3a squared plus 5ab minus 2b squared divided by 6a squared plus ab minus b squared, and then divided by this expression a squared minus 4b squared divided by 8a plus 4b. I'm supposed to simplify this expression now. Okay. So here, first of all, you shouldn't get confused. There is no priority between product and division. You can do them simultaneously. So it means that I factorize everything here, I change it into the multiplication, and I swap them, and I also factorize them. So let us, if possible, do them quickly as much as possible. if one of them is harder, I will do like this. I will go and solve, factorize that one, and then I transfer it to the main problem. So here, if I want to start, this is simple. So let me see if I haven't made any mistakes. So yeah, I remember. So there is a 4 here, sorry. So there is a positive 4 here. Okay, so that expression is a quadratic pattern. So it becomes a minus 2b to the 2. The first one to the 2, 2 times the first one times the second one to the 2. Here I can factor a 2 and an a out. So this becomes 3a, and then it becomes minus 2b. Yes? Yes? And now let us go here. For this one, I need probably go down and try to factorize them individually and then bring them back. So let us do them here. So for 3a squared plus 5ab minus 2b squared. Again, I multiply these two, so the product, if I show it with p, the product should be minus 6b squared. The sum should be 5b. Then it is easy to guess them. So the expressions that I am looking for is positive 6b and negative b. Yes? If I add them, it becomes 5b. If I multiply them, it becomes minus 6b squared. So then I can write it in this way. I can write it as 3a squared. I can break the middle term to positive 6ab, negative b, and then I have minus negative b squared, 2b squared. And then, of course, between these two and between these two, you can start factoring things. So between these two, I can factor a 3a out. This is a left, and then here I have 2b left. And between these two, I can factor a minus b out. Sorry, this is not b. This is ab. Yes? So I factor a minus b out, then a plus 2b is left. And then you can see a plus 2b is the same factor, so I can pull it out. Yes? It becomes 3a minus b. So that's the factorization. So if you're confused here, let me see. Because it was 5ab, I write it as 6ab minus ab, which is exactly 5ab. So I broke the middle term into two terms. And then I grouped them and factorized them. So that is the answer that I got here. Okay, so for the numerator, I know what to do. So for the numerator, I put this expression. So it becomes a plus 2b. And then, of course, you can do some guesswork to simply write them. But I prefer to do this a little bit systematically. And let me just do the second one again. So for the second one, I have 6a squared plus ab minus b squared. Then I would say that I want to have a product which is minus 6b squared, and then I want to have the sum to be positive b. And then immediately I realize one of them is positive 3b, and the other one is negative 2b. If I multiply them, it becomes negative 6b squared. If I add them, it becomes this. So I will break the middle term using these numbers that I got here. So it becomes 6a squared plus 3ab minus 2ab minus b squared. And then between these two, I can pull a 3a out. Then it becomes 2a plus b. Then here I pull a minus b out. It becomes 2a plus b. Then you see I can factor a 2a plus b out. Then 3a minus b is left. And I put it back here. So it becomes 2a plus b. And then I will have a 3a minus b. And then I change this to multiplication and I swap these two. But when I swap these two, I know that I can pull a 4 out from here. So it becomes 2a plus b. And then this is also the conjugate rule. It becomes a minus 2b and times a plus 2b. Yes? Hopefully everything is clear. And now I start simplification. I can simplify vertically as well as cross manner way. So nothing can be simplified vertically here, but here This one and that one, yes, they can simplify it vertically. Here, nothing can be simplified vertically. But you see this one from the numerator of this one and the denominator of this one can be simplified. This one from the denominator of this one and the numerator of that one can also be simplified. And then this a minus 2b from here can be simplified with one of these factors, and a minus 2b is left. Is there something more that I can simplify? No. So these are surviving. So there's a 4 left and that expression. So then it becomes 4 a minus 2b, and then the denominator is this expression. So, by the way, I forgot. 2 and 4 can also be simplified. So 2 by 2 1 times, 4 by 2 2 times. So this expression is just simply 2. 2 times this. Okay. And then I have 1 times a times that expression. So it is just a times 3a minus 2b. And because we cannot simplify or multiply it back, so it becomes 2a minus 4b divided by 3a squared minus 2ab. So that would be the final answer here. Let me check. The answer I provided was the same. So 2a minus 4b, 3a squared minus 2a. Yes, that's also correct. Okay, so the next problem, problem C, I called it a challenging problem. It's not very hard, but of course it is not very straightforward. So you need to have some experience of how to do these problems. So problem part C, we have A, B, and C non-zero real numbers. So what we know is that A, B, and C belong to the set of real numbers and are not zero. So A, B, and C are non-zero. And then we know that there is a relation between these three numbers. B is equal to A minus 1, and C is also equal to A plus 2. We want to simplify the following expression. A squared, B squared, C squared minus A squared, B squared minus C squared plus 1 divided by A squared BC minus C over B plus B times A squared minus 1 over B squared, the whole fraction plus 1. Okay, so we are supposed to simplify this expression. Okay, so this is a question mark. So what I do, again, I will try to do, this is not a standard problem, so you need to be a little bit more creative. First of all, but the ideas hasn't changed actually, so I will try to, this is a rational expression, not rational, because, yeah, that's the rational expression at the end, because I can multiply by the least common multiple of the denominators, and it turns out to be a fraction of polynomials. Okay, so what can I do? If you look here, the idea is to try to factorize if possible. I take these two, and I will take these two. So this will give me the factorized form of the numerator. Yes? Okay. Let me again do the numerator and the denominator separately. So the numerator, let me write n for the numerator. So the numerator is equal to, I take a squared, b squared out from these two. Then c squared is left here, minus 1 is left here. Then I take a negative sign out from these two. So it becomes c squared minus 1. That's good. Yes, this grouping was good because now a new common factor emerges. So I can pull it out. So then it becomes c squared minus 1. Then I will have a squared, b squared minus 1. Yes, I pull this expression out. I divide this by c squared minus 1. I get a squared, b squared. I divide this. I will get 1. Of course, I can factorize it more, but you know that the goal is not factorization. Let us not be in a hurry. So keep it in that way, and let us go to the denominator to see what happens. Of course, if I need to factorize it more, I will definitely do that later. So let us come here and then check the denominator. So the denominator, first of all, I would prefer to multiply this inside. So then it becomes b squared, ba squared. And when I multiply b by 1 over b squared, this 1b and one of these b's are canceled. So 1 minus 1 over b is left. Yes? Okay, now what can I do? I can take this one with that one. A squared b is in common, so I can take it out. So it becomes a squared b. Then from here, c is left. And from here, positive 1 is left. But between these two, I can factor a minus 1 over b out. Yes? So 1 minus 1 over b out. Then from here, c is left. From here, c plus 1 is left. Yes, usually we don't factor out fractions. But I told you that the reason that I call this problem challenging is not that standard. You need to be able to be a little bit more creative. So, but this is mathematically intact, healthy, yes? I multiply minus 1 over b there, it produced me this, and I multiply minus 1 over b there, I will get that one. So that's everything is correct, but the good point is that I can immediately see that this pattern emerges. This common factor emerges, so I can pull it out. So it becomes c plus 1, then I will have a squared b minus b. Of course, I can do better. I can pull everything out, yes? So let me just do that, okay? So I will take 1 over b out, 1 over b c plus 1 out. So let me don't write this one first. And then if I pull everything out, minus 1 is left. C plus 1, I pulled it out, so a squared b is left, but because I am factoring a 1 over b out, this b turns into b squared. Yes? If you don't believe, let us check. 1 over b multiplied here. One of these b's and one of those b's are canceled, so I will get a squared b back, which is exactly the one here. So hopefully you can realize what's going on. I am factoring this expression out. Minus 1 is left from that one. C plus 1 is actually pulled out. So what is left is a squared b. And then, so a squared b, I need to divide it by 1 over b, which becomes a squared b squared. So this is what I have written here, yes? Let me explain it in that way. So for example, for example, when I have 4x plus 6 and I want to take 2 out, what do? You write 2x. Of course, it is super simple. You can do it in your head. But in principle, you divide this expression by what you pulled out. Yes, that's the point of factorization. So now if I take this one out, so it means that I have to divide this. So I go to a scratch paper. I have to divide this expression by the one that I pulled out. But the one that I pulled out is this expression. Yes, so you see that this one and that one are gone, and this 1 over b will go back exactly that the one that I did here. So this is why this is a squared b squared. Okay, so I think now everything is clear, more or less. Now I go to the question mark. So the question mark becomes equal to. In the numerator, let me write this one, c squared minus 1. Then I will have a squared b squared minus 1. In the denominator, I will have this expression, yes? So it is 1 over b, c plus 1, and then a squared b squared minus 1. You see, and then I have another plus 1 at the end. So here, even though I can factorize this even more using the conjugate rule, but there is no point because here simplification is important, and that appears as a factor here and there, so I can simplify it. But then you realize that this needs to be factorized more because that's this gives me a factor that I can simplify it with the denominator. So then this becomes c minus 1, c plus 1, and then in the denominator, I have 1 over b multiplied by c plus 1, and then I have 1 at the end. And then this c plus 1 and that c plus 1 are gone. But then c minus 1 divided by this, so this b goes up, yes? So this becomes equal to, I will give a denominator 1 to this in my head, and then I will multiply these two numbers which are far away from each other and put the answer in the numerator, and multiply these two numbers which are close together and put it in the denominator, which I don't need to write. Let me write this is 1, and then I have 1 at the end. Yes, so this becomes b c minus 1 plus 1. But can I simplify this expression more, because the answer that I provided is not this answer, even though that is much simplified. That's very simplified to a large extent. But the answer that I have provided as the answer is a squared. Why is that correct? So it means that I need to eliminate b and c in favor of the variable a, which the problem has given the answer in terms of. So what I do, instead of b, I put a minus 1. So I put a minus 1 instead of b, according to the assumption in the problem. And instead of c, I put a plus 2. Yes. But then I have a negative 1 here. And then I have a plus 1 at the end. But this becomes exactly a minus 1. This becomes a plus 1. And then I have plus 1. And then this becomes the conjugate rule. It becomes a squared minus 1. Then I have a plus 1. This simplifies to a squared. And this is the answer that I have provided. Of course, this is much simpler. Not much simpler, but simpler than this version, yes? So that is a better answer to this problem. Good. And finally, the next problem. And you see that I have divided the problems. These problems so far is focused on the material covered exactly in lecture 19. But these problems, the one problem is left here. It's focused on the previous lectures mainly. It doesn't mean that you're not allowed to use what you learned in lecture 19, but the main focus of it is the previous lectures. But here, the problem is very simple actually. So let us solve part D, and then we finish this. Let A and B be two distinct positive real numbers. So A and B are not the same, they are distinct, they are positive. And above that, we have this relation. A squared minus 2b squared minus ab is equal to 0. And then I am supposed to find the exact value of this fraction. Yes, that is the question mark. We want to solve this problem now. So if you see, I can factorize this polynomial. Of course, this is a polynomial in terms of a and b. I can factorize it in this way. It's not that hard, yes? A squared minus 2b squared minus ab is equal to 0. This implies that instead of minus 2b squared, I can write it as minus b squared, again another b minus b squared, and then I have minus ab equals to 0. I can take these two, and I can take these two together. The first one is a conjugate rule. It becomes a minus b, a plus b. And then between these two, I can factor a minus b out. From this one, positive a is left. From this one, positive b is left. And this is equal to 0. But that is good, because you see that a common factor emerges. I can pull it out. So this gives me a plus b. From this one, a minus b is left. And from this one, minus b is left. Yes. Now let me check that everything is okay. Okay. Everything is right. But then a minus 2b minus, sorry, a minus b becomes a minus 2b. So this gives me this condition. The product of two numbers is equal to 0. So either that those numbers, so either this one is 0 or that one is 0 based on the zero product rule. So this gives me that either a plus b is 0 or a minus 2b is 0. Yes? But then a plus b cannot be 0 because of this condition. A and b are positive. So if they are positive, the sum cannot be equal to 0. So not possible, this one. Okay, so the only thing that can happen is that a is equal to 2b. Yes? And the reason that they have mentioned that they are distinct is used because here a minus b is in the denominator. If they are not distinct, the denominator is 0, this is not defined. And then everything becomes clear. So if you don't mind, let me just write it here. So the question mark becomes equal to, instead of a in the numerator of the question mark, I put 2b, and then I have another b there. Again, the same story here, 2b minus b. So instead of this a and that a, I replace 2b. In the numerator, I will have 3b. In the denominator, I will have b. And these two b's are cancelled, so I am left with 3. So the answer to this problem is 3. Okay. So, as I told you in the beginning, you can find a link for the problems that I solved here right now below the video. On top of that, you will also find another link where will provide you with another set of questions related to the topic that I covered in lecture 19. And so the next video would be the solution of those problems. And after that, we will move on to the next topic, and that would be, as I told you, addition and subtraction of rational expressions. We will have much more interesting and exciting problems when we cover that topic. Okay? Okay, so I hope that the video was useful for you. I hope that you can subscribe to my channel to support me, because if you see that everything I have done is completely for free, so it would be an encouragement for me, so that if I can see that what I present here is actually interesting for you and you are following them, and if you really have some ideas that I can improve the video, you can leave the comments below the video. And if you really like the videos, I also appreciate that if you can give me a thumb up. Okay? Until the next video, goodbye.